The term composition of functions refers to combining two functions so the output from one function becomes the input for the other function. To better understand what this means, let's consider an example. Let f be a function where the domain is the McDonald's menu and the target is the set of real numbers. The function takes any menu item x to the number of grams of fat in menu item x. For example, f of a Big Mac is 22, since a Big Mac has 22 grams of fat. F of a large fry is 25, since a large fry has 25 grams of fat. Now think about the function h with domain non-negative numbers and target all real numbers, where h of x is the number of calories in x grams of fat. Since there are 9 calories in every gram of fat, h of x equals 9x. Can you use these two functions to make a new function that tells us something about the calories from fat in a McDonald's menu item? We can apply f to a Big Mac and get 22 grams of fat. Then if we apply h to 22, we see that there are 198 calories from fat in the Big Mac. We can do the same thing for a large fry. Applying f, we see that there are 25 grams of fat, and then applying h, we see that there are 225 calories from fat. So first, we're applying f, and then we're applying h. It is called function composition, and we write h composed with f of a Big Mac. More generally, we say that h composed with f of x is equal to the output of h when we input f of x into h. Let's see an example of how this works. Given f a function from the real numbers to the real numbers, with algebraic rule f of x equals x squared plus 1, and g a function from the real numbers to the real numbers with algebraic rule g of x equals 2x, can you calculate the algebraic rule for f composed with g of x? This means we input g of x into f, and g of x equals 2x. Looking at the formula for f, we see that f takes the input, squares it, and adds 1. So if we square 2x and we add 1, we end up with 4x squared plus 1. Can you calculate the algebraic rule for g composed with f of x? Will this be the same as what we just calculated? To compute g composed with f of x, we want to input f of x into g. So we input x squared plus 1 into g, where g is a function that takes the input and multiplies it by 2. So we end up with 2 times x squared plus 1. Here we have two functions, f and g. We do not have an explicit formula for f or g, but we do have a table that summarizes some values for f and g. Can you make a table for the composite function g composed with f? What is g composed with f of 3? We want to plug f of 3 into g. Looking at the table, we see that f of 3 is 1, and g of 1 is 3. So f composed with g of 3 equals 3. What is g composed with f of 2? We calculate the value of g when we input f of 2 into g. So we look at the table to find that the value of f of 2 is 2, and then look at the table to find out that g of 2 is 5. What is g composed with f of 0? Compute g composed with f of 0, we calculate the value of g when we input f of 0. So we look at the table to find the value of f at 0 is 6. And then we calculate g of 6 is 8. Here we have two functions, f and g, given by their graphs. F is the yellow graph, and g is the blue graph. What is f composed with g of 0? To compute f composed with g of 0, we calculate the value of f when we plug g of 0 into f. So first, we look at the graph to find the value of g of 0. G of 0 is 4, and f of 4 is 7. Today we motivated composition of functions with a real-world example. We examined the general phenomenon, and then we computed the composition of functions using formulas, tables, and graphs. You should now be ready for the practice problems.